Hi and welcome to my video on integrating rational or polynomial functions. So I'm going to just run through 2 or 3 examples, show you how to do this, hopefully you can carry it from there. Okay, we'll start with a really simple example with a nice whole number, and that will be that our rate of change to y dx is equal to 3x to the power of 11. Why not 11? It's a bit larger than we usually expect, but you know, the process is exactly the same. So to work out the value of y, we put in that integration symbol you saw in the last video, 3x to the power of 11 with respect to x, and then we go through the process. And the process is that we leave the 3 there, leave the x there, increase the power by 1, giving us 3x to the power of 12, and we divide by the new power. And of course 3 and 12 simplify reasonably nicely, and that leaves us with a quarter x to the power of 12. But of course I have forgotten something which we spoke about at the end of the last video, and that is the constant of integration, plus c. We should always have a plus c on the end, just to recognise that we don't know if there was a number on there or not. Later on we'll learn how to deal with that in some particular situations. Let's look at a second situation. The question can be written in a lot of different ways. So this time, let's say it's just a straight integration, but this time it's an integration of 7 over x to the 3 dx. Okay, be a little bit wary of this. This looks a little bit like, oh no, really, maybe there's some integration chain quotient rule or something like that. Looks a little bit more confusing. There is a special case. If this wasn't cubed, if it's just 7 over x, that's a special case we'll deal with later. But for now, this can just really simply be written as the integral of 7x to the power of negative 3 dx. So we just apply that index law. And of course that simplifies down to be 7x to the power of negative 2. If you raise negative 3 by 1, you get negative 2, and I divide by the new power, and I add the constant of integration. And then this is equal to negative 7 over 2, or negative 3.5 x to the power of negative 2. We did start with our power as a positive in the denominator, so I'm going to return to that as well. And that gives me negative 7 over 2x squared. So it's a good practice to return to the form you started in as a rule of thumb. And let's do one last one. This time I'm going to show you how we can break it up into pieces. Of course I forgot to follow that plus c through. You have to watch me on this one. And that is going to be that this time we'll integrate the square root of x, I'll show you this special case, plus 7x minus 2. So individually these are all fairly easy terms to integrate, but the expression itself involves a little bit. The first thing I'm going to do, and you have to be careful of this, because I've seen it before, these two terms here, 7x and minus 2, they're pretty easy to integrate. We could just do that now. Sometimes people will start to transform this using index laws and integrate these at the same time, and they'll actually end up with a poorly communicated solution. So let's not do the integration until we're prepared to integrate everything. So I'm going to leave it as an integral. I'm going to write this down at x to the power of a half plus 7x minus 2 with respect to x. If you're using an online computing software, maybe your calculator, sometimes it's beneficial just to put brackets around it so that the with respect to x is applied to everything. But if you're working in an exam or something, it's not as important. Basically, your integral sign bookends with your dx to give us that rule. So I'm going to integrate this. Now I can integrate everything. I'm going to do it all in one go. So x to the power of a half becomes x to the power of 1.5, which I write as 3 over 2. So that half increased by 1 is 1.5, and we divide by the new power, which is 3 over 2. And then 7x becomes 7x squared divided by the new power. And minus 2 just becomes minus 2x. If you're a bit worried about that, consider it like this. The integral of minus 2 is equal to the integral of minus 2x to the power of 0. And that of course is equal to, sorry, I need an equal sign there, minus 2x to the power of 1 over 1, which gives us this negative 2x. So there's a reason behind it, but right now you know a constant goes to a linear function because you know that when you derive negative 2x you get negative 2, and that's fine. Of course a plus c, I'll just simplify my fractions. Dividing by 3 over 2 is the same as multiplying by 2/3. That reciprocal, and then I get plus 7 over 2x squared minus 2x plus c. And of course, I probably should put this back in square root form, but I might just leave it like this for now due to space. And that's our integration. So these are polynomials or rational functions. We've got negative indices here, we've got fractional indices there. The rule is exactly the same. And the rule is that to integrate ax to the power of n with respect to x, it's equal to ax to the power of n plus 1 over n plus 1 plus c. That's our rule for integration. And we can use that rule for any polynomial term or any term that indeed is an x to the power of something. All the best.